Gentlemen, good afternoon from me again. I hope you will not asleep this late hours. What I'm talking about looks a little bit eye-catching, 40 watts for less or for only a few dollars, but it's true. How can I switch the slides? Yeah. Okay. Yeah. What I'm talking about is directly the opposite what we learned in the morning from Charlie, because Charlie showed us an feed horn with an amplifier on the backside of the feed horn, very lightweighted, very small. This is the opposite. It's big, it's heavy, but it's there. So the Charlie's solution is expensive and it's not available at the moment, and you have to build it up. This is probably in your shack, and the people who are interested in 9-centimeter work, they may already have it. There are two different Toshiba amplifiers available in former times on the market on eBay from Pyro Joe or from other sources. One is the model A, 2683A and 2683B. The model A is the model everybody wants to have. It's the 40-watt model, and if you put it on the bench without any modification, it can run 45 watts, 50 watts without anything what you have to do. Only a power supply has to be connected. And the B model, I think, or for my opinion, there are a lot of these amplifiers, version B, still in shacks unpacked because they are all brand new, is rated 20 watts. And I checked the 4 of them, brand new amplifiers. I unpacked them directly. They came directly from Japan. I unpacked them, and they all run 30 watts. So the 20-watt model is capable of running 30 watts. But if you open them and measure what's going on, then you will see that the internal power supply for the output transistor decreases the voltage. So the internal power supply is not capable to run higher power than at least 30 watts or so from this B model. But the B model is the better version, because the B model can be converted to a 65 to 70 watt output model. This is what I see on my meter, and I saw it several times from several amplifiers. The problem is, from the A model, there is an internal series regulator, a Darlington transistor S2SD1297. It's a very old transistor, and all of the publications you can read about that said that it's very problematic to set up the bias and to tune all the pots, and you have to keep the output voltage, the DC bias voltage, the external DC bias voltage very stable, and it's all tricky to run this. And even from the A model, there is only one internal series regulator, this Darlington transistor, and you cannot vary driver stages and output stages separately. If you vary something internally in this A model, then you vary everything. And even the first MMIC limits drive power due to that saturation. I have one of these models in my tropo station over a long time, modified this, and it happened what many of us happen. It burns down because this transistor burns down, and the fact was that the first it gets very hot, and the first MMIC breaks, and then I omit the first MMIC, make a line, a small coaxial line from the input connector to the second stage, and I see that I can get much more output power than before, because the first MMIC was a limiting factor in the original amplifier. This is a very raw drawing. I had no time to make a better one. From the 40-watt model, you can see it starts with an MMIC, then comes a stage where you can regulate the gain. It's an attenuator here. Then a second stage came, a driver, a pre-driver, and the final stage. This is a model with a banded output connector. You can easily see them. They are banded. And from the B model with a lower power, this is a rectangular output connector. I looked to all these voltages, looked what are the pots done, and make my investigations. And I see that when I open both models, they have all the same transistors inside. So why is the one model for 40 watts and why the other model for 20 watts? There is no real reason. They have the same driver transistors, the internal PSU power supply, but can only deliver for drive power, DC drive power for 30 watts. So, but the internal PSUs are adjustable over a wide range, and the next thing is that the 90-degree angled output connector maybe limits power. Yesterday I had a discussion with Zenek, and Zenek said don't buy angled output connectors, SMA, because they cannot handle high powers. That's the reason that the engineers from Toshiba probably put on the output a so-called low power SMA connector, because you cannot use it without any failure, maybe for over longer times with high power. So what I did after the modifications of all the other things, I exchanged the input with the output connector. So the output connector was right angled and the input connector was a straight SMA connector. And I exchanged it, and now I am on the safe side because my output connector now is not power limiting. And the recommendations I will give now improve the output power by more than 4 dB of this amplifier. This is the B model, and the difference you can see, the B model has some discrete transistors, or maybe MMICs, small MMICs. I couldn't find out what it really is. And the input's the same attenuator here, 2 devices before here, 1 device later, and then these 4 identical devices from the other thing. The only difference is that they have 2 series regulators here. This one I keep untouched. This is the one can only deliver the bias current for 20 watts output with the right angled output connector. This is the connectors I exchange. I put this connector to this side and this connector to this side. And what I have done, I cut out this regulator transistor. And this is removed the old Darling transistor. I cut it out by all 3 legs. Remove the remainder of what's in the board, because if you don't remove the wires, if you cut them out and you do not remove the wires, then they can fall down and make a short underneath, and you have to remove the whole circuit board. And then this is the place I removed it. Here, this was the old place where the series regulator, where these are these 3 connectors: base, drain, and source. And I take out these 3 remaining wires. And instead, I mount a power MOSFET. It's all on the CD. The details on that are on the CD. You can read it on the CD. And the old base connection of this is the left thing. The old base connection is used to drive a small relay that all the other circuits are untouched. You can use the amplifier as you can use used before, because this drive switched on this power regulator, and later on it switched on a small relay to bring on TX, the whole amplifier. So this is the new power MOSFET. The base is straight upward, and drain and source you must cross because this has another different layout than the old one. This is a simple drawing of the new board. It's only a transistor, a FET here, only a transistor, a small 9-volt power supply, and the relay to switch it on, and the connection for the relay is for the old base connector. So nothing more to change. This is the layout of the small board, and the parts you need, only this is the expensive part, maybe $3, $4 the price, a small relay, power regulator, and some capacitors and a diode. So very, very cheap. That's the drawing of what I have done. And this is the board, how it looks. and I put it on top on the new series regulator built in. And this is the board on top on the old places. The new series regulator is underneath, and soldered it together. And this is how the amplifier looks when the new board is in the place. So this is a work for, let's say, 3 hours or so. Then it's finished. And some remarks for the DC connections. There are several papers describing how complicated it is to run the DC power, because the amplifier needs 20 amps under full load, and you have 8 connectors, and there are recommendations to exchange the whole 15-pin connector and bring in other lines. But for my opinion, it was good enough to use these all lines, and then each line has to transfer 5 amps, and this is not a problem. I never saw big drops in voltage from the outside world to the inside world due to the connector. This is like it looks. Excuse the picture is a little bit unsharp. These are the connector lines here. I connect them all and going over to bigger lines for the outside world. I use heavy copper loudspeaker lines, loudspeaker wires to transport these 20 amps for each amplifier. This is how it looks, these big loudspeaker lines. And my power supply, this is a switching power supply. I put underneath the dish, so it's protected from rain a little bit. And the line to the feed horn is only very short. It's only 2 meters, so no loss in voltage to know. And the unused pins of this connector, there are several unused pins. Number 6 and number 14 are used for internal forward power and refracted power measurements. You can see it from former papers that they all give recommendations, but they are all no very clear. Nobody knows exactly how to use it and what is what, who is who on all the lines. And I checked all the lines, what's going on, and I found out that on the pins 4, 5, 8, and 15, some signals are here. High output alarm signal, low output alarm, SWR alarm, and monitoring the internal 5-volt voltage. And 2 pins are unused. And I use these 2 pins for bringing out. These are 2 pins here, and the lines are these both connectors here. The inner, this is 1, 2, 3, and then number 3 and number 4, 5, 6, 7, or 5, 5, 6. And these both are the forward signal and the reflected signal, internally measured in the amplifier. And I cut it a little bit from the insulator here, and soldered 2 wires, one each side, one here, and bring them to the spare connectors, and then I have a power meter for less. So this is how the control signals measurement can look. You see all these alarm signals in the amplifier. I put this simple circuit, and I have a red and green diodes, and you see on one step. Is the amplifier still alive? It's all good. It's all in the range. Very simple. This is if you use 2 amplifiers, and you have 2 times these control lines. And I use a simple 74L SO8 and have only the same amount of diodes. Otherwise, you need double the diodes, and then you may be a little bit confused maybe of all the lights, and you never know what's going on. So. Very good cooling is absolutely necessary, because the usage of a very good heat sink with a very large surface, it must not be a big sink, it can be small, but the surface must be large. So they're very effective heat sinks are necessary. From Kuhn Electronics, there is one heat sink, the SK125, is very good for this. And I use additionally 2 high-efficiency blowers to cool down the amplifier. And if you don't do this, then the output will decrease rapidly. So cooling is absolutely necessary. And to control these things, I use a temperature regulator like this from W1GAZ. This is a similar thing to control the speed of the blowers. This is how it looks. This is the high efficiency heat sink, and on each side is an amplifier. This is a rear view of the whole setup. You can see the input lines here, and there are some stuff around. That looks a little bit crowdy, but it works. So this is what I have done later. I modified, as I said, 4 of these amplifiers. I put 2 together. Each of the amplifier deliver around 70 watts, 65 to 70 watts. I take a Ratrace coupler from a company in Holland, a very cheap thing here, and it's an air coupler with the losses below 0.2 dB, so I don't lose power from here. Remember, I exchanged these both connectors. Now I have the right angle connectors at the very low power side on both sides, and the straight connectors on the output side. Have a 6 dB coupler here, a resistive 6 dB coupler, and on one side a variable delay line, so I can match the phase, and there's no matching necessary at the output. So no additional devices are necessary, and no power reduction. And at the end I get out roughly 120 watts, or a little bit more maybe, going to the TX side of the septum feed, and on the RX side is a well-known things here. So this is a Ratrace coupler, how it looks. And you can see this is the TX side of the feed here, of the septum feed, and these both lines are coming from the amplifier. So again, the rear view a little bit more. You can see this is my device with the 4 diodes. I can easy check up, are both amplifiers still alive, all voltages okay, power in the range I like, and the output of these amplifiers are 130 to 140 watts, but I lose a little bit in the Ratrace coupler. So 10 to 12 watts are lost in the coupler, so you have to deduct this from this. At the input, I use a resistive 6 dB divider, as I said, and a phase shifter, and the multi-alarm display is this to see what the amplifiers are doing. So this is a receiving side, thanks to G4DDK. This is a G4DDK amplifier, very, very low noise figure. But if you measure a noise figure not at this point, this is very good. If you measure it after the relay and after all the connectors, you find out it is another 0.2 dB. So this is not what we want, because we have these excellent amplifiers, preamplifiers, and then we lose in the input. So this is not a right-angled thing, it is a banded thing. So I make comparison measurements between the banded and the right-angled, and the right-angled are more or less reduction than this banded. And even these are the best, highest prices devices here, but the loss is still 0.2 dB from here to here. And I measured a lot of different relays. This is a brand new relay from, I think, Toshiba, something, or Panasonic. And I measured all the surplus relays here, and between it, it's all more power reduction from here to here. So these 3 devices, this adapter, and the relay is the best combination I ever could find out for 9 centimeter. So results and conclusion: 120 watts RF output are possible if you have these amplifiers on hand. If you have to buy them, maybe Charlie's solution is the better one. No high power relay is needed due to the septum feed, so you don't need a high power switch there. You need, this is a disadvantage, you need 12.6 volt and 40 amps drawing current. Input generated by a small switching power supply. You saw it behind of my dish. And the modification takes only a few hours and costs about 10 to 15 US dollars. And last not least, 9 centimeter is a great band. And that you have an impression what I'm talking about, this is a thing. So this is my complete 9 centimeter EME station. So both amplifiers are here. You can see the feed horn, the couplers, the blowers, amplifiers, all in this box. So thank you very much for listening.